Figure 20.5 Input and Output Stream Iterators. One of the most fundamental concepts of working with the standard template library is the use of this concept called iterators, which have semantics that are very much like the concept of pointers with arrays, where basically you can aim a pointer at an array and then you can add values to the pointer to move into the array. You can subtract values from a pointer to move backwards in the array, and you can even with a pointer use subscript operators to jump to specific elements within an array as well. Now, the interesting thing is that you can also treat input and output streams like collections of data, and that's what we're going to demonstrate in this first example. And because of the power of doing that, it allows you to write some very expressive statements, as you'll see later on when we combine the concepts of the containers of the STL with the so-called algorithms of the STL, which allow you to perform various tasks on those containers, and the use of iterators. When you combine all three together in one statement, you can do some incredibly powerful things. So we'll show you that in later examples. To start, however, let's look at the running first program from this lesson. And here we're being asked to enter two integers, so I'm just going to go ahead and enter 20 and 30 and press enter, and you can see that we have a simple addition program here that just shows me the sum of the two numbers. The thing that's different about this example is the fact that we're now working with iterators. And one of the things you'll notice is that even though we've included this standard header file called iterator, we don't have any using declarations following the header file, and the reason for that is for portability. In this lesson, we are frequently going to qualify names with the std : and one of the reasons we wind up doing that is because as we tested the examples from this lesson across multiple different compilers, we found that sometimes with the complexity of declarations that some compilers did not work as well with the examples. Now, that is not really the case nowadays with the most recent compilers. However, to be as compatible as possible with as many different compilers as possible, we chose, when using the standard library, the standard template library classes, to qualify their names fully inside of the code. So you'll see that in many of the examples throughout this lesson. Now, we've included the Iterator header file, which gives us access to a couple of interesting iterators. We have the type iStream_iterator and the type oStream_iterator. And as you can see, each of these is a template. That means that we can specify with these iterators the exact type of data that we intend to work with through the iterator. And basically what we're doing here is creating an Inputstream Iterator, something that can read data. Specifically, this one can read only data of type int. So this is a kind of very type-safe way of doing input, where we're saying anytime you use this iterator, it is only going to read integers. The name of the object that we're creating is input_int, and that's going to work very much like a pointer, as we'll see. And the stream from which it will be reading is the cin stream, but it could be any type of stream. It could be a file stream, it could be a stream representing data coming across a network connection, it could be a stream of data coming from an object in memory. Anything that is a stream of the types related to cin, specifically of the type iStream or one of its derived types, can be used as the argument to the constructor for an iStream iterator. So we declare our iStream iterator of type int, and then we show you semantics that look very much like a pointer. When you dereference an Inputstream iterator, that's the point at which it reads a value from the stream. So this line 17 is like a cin statement that reads a value into the variable number 1. So here we're saying assign to number 1 the value returned by the dereferenced iterator. And if I were to dereference that iterator again in a subsequent statement, it's going to read that same value again. However, if I tell it to move to the next position by adding 1 to the Inputstream iterator, that's going to move the iterator past the current input to the next value to be input, and then when I dereference the pointer again, I get the second value. So here in line 17 we read the first integer the user typed, and in line 19 we read the second integer the user typed. Now if we're not going to read anymore, we don't need to increment the iterator again here at line 20. If on the other hand we want to keep reading more integers, we would have to increment the iterator once again. Now in line 22 we also wanted to demonstrate outputting using iterators. So here we create an OStream iterator for a type integer which only knows how to output integers. We called it outputInt, and we initialized it to output all of its data to the standard output object cout. And again, anything that is an output stream can be used as the argument to the constructor here. Thus, I can output integers to any type of stream that I want. And then finally, we output first the string the sum is using cout, and then to demonstrate outputting an integer, first we add the numbers number 1 and number 2. Then we take that value and assign it to the dereferenced output iterator, and doing that is actually going to take the value and place it on the output stream. And then finally, I'll output an endl to output a new line and flush the buffer. And as you saw in the output, that indeed it was able to output the value that we just added together on the right hand side of the assignment here at line 25. Now, of course, this is kind of a strange syntax to be using for just standard interactive input and output. It would be much easier to just use cin and cout as we have done in many prior examples. However, these concepts of input and output stream iterators, when combined with the containers and algorithms of the standard template library, can create much more powerful expressiveness, if you will, for writing certain types of operations. For example, I can use an output stream iterator and the copy algorithm to copy the entire contents of a collection of a container out to the standard output stream in one line of code, as we will do in many subsequent examples.